I'm Rishit, and a bit about me. I'm a 10th grade student and a past TedX Untitled speaker. I'm also an AI and cloud enthusiast, and I've represented my country, India, in various international level hackathons and competitions, and also won a few. And if you're interested in the research part or stuff like that, I've also written 7 research papers. Pretty interested in research too. So if you have something up your mind, I'd be more than happy to help you. I have also listed my portfolio website down over here. So you can know all about me, all about what I do over here. I make some pretty good open source content too. I'm pretty active on GitHub. I write a couple of blogs too. So on Medium. So yeah, you can go ahead and follow me on any of these. And that's about me.
So hi guys, I haven't made a slide like Rishit. Okay, since I was like slightly busy these few days, but no problem at all. So I'm Vijaya. I think you've heard my voice. I think so many times with by now. So I'm currently a student ambassador, just like Rishit, of course. We're all student ambassadors, and I just graduated from Bristol Dubai campus with a major in computer science. I'm currently transitioning to my master's degree. So my interest is like just like research. I'm interested in research papers, and I'm more focused on like journals and yeah. So that's going on. So and of course I'm getting into hackathons nowadays with some of my college mates and all. And I do write a few blogs, but I haven't gotten the time yet. So that's it. So hi guys. So if you have any doubts or anything, just contact both of us on our social medias, and we'll definitely talk to you guys. So no problem at all.
Yeah, sure. And before we start with this session, I just wanted to tell you, me and Vijaya, the speakers for today, will be constantly monitoring the chats over here. So if you have anything to say, anything to ask, the chats are always being monitored. So we'll take a look at the chats, and yeah, if you want to kind of let everyone know about yourself, you can do that in the chat too right now. Great. So let's get started.
And just a small request, guys. If you since it's going to be a more linear session today, we'll have a Q&A session for all of you people. If you're like unable to type your doubts out. So until then, can you please mute yourselves? Thank you so much for the support, guys. So go ahead, Rishit.
Great. So first off, let's start with the idea of ML. So what's ML all about, and why should we care about it? First off, and you might have heard ML a lot these days because it's quite in trend today. If you see hashtag ML, it's there on all social medias. So quite in trend these days. So why is ML so much being explored, and what's the intuition behind ML? So let's start with that. Um, so in traditional programming, what you do is you do something like, if you're writing a simple Python or C++ code, let's say, or any programming language you have worked with, what you do is you pass in the rules, that is maybe some if and else's, and you pass in the data, maybe some data from a database or a cloud hosted or a cloud managed bucket or something like that. You get the data, you get the rules, you feed in the rules, and with traditional programming, what you get back is the answers. So you feed in the rules, that is your algorithm, which you code. You feed in the data, and you get back answers. What ML does is it reverses this. It flips the axes. What it does is, instead of you having to pass in the data and the algorithm and getting the answers out, what you now do is you pass in a lot of data and you also pass a lot of answers. So let's say I have something like a lot of data about dogs and cats, and I want to classify between them. How would I do it with traditional programming or traditional algorithms? I would just do something like, if uh, something which features between is distinctive between dogs and cats. So maybe you say, if the photo looks has this feature, or the photo has, let's say, some feature, or something like that, which you code in. Or let's take another example. If you want to classify between an orange and banana, or with traditional programming, you would do something like tell the algorithm that if the fruit you see is orange in color, it is orange. If it's yellow in color, it's banana. You see the shape and so on. But with ML, what you do is you pass in the data, that is photos of dogs and cats, or oranges and bananas. And you also pass in the answers saying which image is what. And what ML does is it gives you the rules out. So the algorithm you pass in traditional programming is then returned to you. ML will find out the features which are there in the image, so that you can identify two images, or distinct two images. That would be better. Yeah, that's again just an example of ML, but that's essentially what ML does. Let's talk about act recognition. So again, showing how ML is different from traditional programming. So let's say I want to do activity recognition, which you can see over here. So a person is walking. How do I detect that? Well, simple. I'll just say if the speed of the person is less than 4, then he's walking. Great, I solved the problem. But what if your friend comes and he's running? You'll do, okay, no problem. I'll just make a small edit to my code. If my speed is less than 4, he's walking. Else, if the speed is greater than 4, he's running. Great. Now your other friend comes up and he's cycling, let's say. What would you do then? Just add another line of code. The speed is less than 4, it's walking. Between 4 and 12, it's running. And if the speed is greater than cycling, I again solve the problem. But then pops up again, and this time he's playing golf. That's when your traditional algorithms start to fail. So the traditional algorithm does not know what to do because you have not written rules for it. So as to what it would do when it sees a person golfing, or doing something like or doing something which cannot fit into these conditions of speed. I want you to take a look back at this diagram. Remember what I said about traditional programming and machine learning, how it flips the axes. So instead of now, so what you did over here was you gave it a lot of data, that is images of people and their speeds. That was the data. You pass in the rules. That was the if and else's. If speed is less than 4, do this, or else do this, and it gave you the answers. That is it walking, running, or something like that. What I want to do with machine learning instead is I'll pass in the answers. So let's take a look at the machine learning part of this. Okay. So what I'll do is I'll convert all of these images into something like binary or something else, which we'll take a greater look at maybe sometime later, or later in this event. But so I pass in a lot of this data, which is images of people, and maybe even images of person playing golf. And then what I'll also do is I'll pass it labels. So I'll pass an image saying this is an image, he's walking, this is an image, he's running, and so on. I'll pass a lot of these images, maybe even including golf. And what my machine learning model would then do is it would figure out the features inside this. So what makes this image look like the person is biking? So maybe you would see I have 2 tires and stuff like that in the image, which means the person is biking, and so on. Now that would be something which would be taken care of by the ML algorithm. So so that's how ML is different from traditional programming. And you also see a very small example of why ML tends to work better when you have a large amount of data than traditional algorithms. So what if I told you, instead of these four things which you can see over here, walking, running, biking, and golfing, I had 1,000 of these. I had 1,000 activities instead. Just think about it. I have 1,000 different human activities. Could you write a traditional algorithm for that? Would I be able to, would a team of engineers maybe be able to look at so many images and tell out which is the feature and then code them in? Do you think that would be possible? And it would work well in real life scenarios too. So that's when ML comes into play. You have a large amount of data. You want to figure out patterns from it. Again, this is just one example of it, but uh, but uh, but a common use case of using ML. So you just saw how it can be used to do stuff like this, uh, and it automatically gathers the features for you. So again, that's something cool to know. So where does all of this fit? I told you about the difference between traditional algorithms and machine learning. So where does all this fit, and how do you actually do ML? So what are the different ML algorithms and stuff like that? I just told you that I would do the feature recognition from images, but I never mentioned how I would do it. So let's take a look. Uh, what I'll also keep in mind is this is a beginner session. So uh, I'll assume that you don't know a lot about ML, and yeah, even if you don't know about ML, you'd still be able to make sense about it, and we'll cover everything from the basics. Great. So I'll not waste much time over this diagram over here because it's like so common. I guess everyone might have seen this, but but for the folks who have not seen this, I'll kind of explain it very quick so we can get to the cool part, that is coding an ML algorithm. So uh, there's this thing that machine learning is a subset of artificial intelligence. So what's artificial intelligence? I hate definitions. So uh, maybe if you want to ask me a definition, I'll maybe answer that. But I would like to explain it more in my experience or my terms. I don't like a lot of these definition stuff. So I think like according to me, how I define AI would be something that mimics human behavior, a subset of which is ML. What does ML do? ML is something which mimics human behavior, of course, because it's a subset of artificial intelligence. But it does so constantly improving with time. So if you train an ML algorithm, it improves with time. And that's what I want to do. And that's a subset of AI. So what's the deep learning stuff then? So deep learning is again a subset of ML. So it will it will agree to both of these things, which is mimics human behavior, improves with time, and it works like and it uses neural networks to do so. So neural networks are they are a lot in trend right now, but if you don't know about them, uh, neural networks try to mimic how the human brain functions, and that's how our deep learning algorithms work. So a bit about it. Now I want to get to the subsets of machine learning, or I would rather say, how do you do machine learning? There are a few things to note before we dive into the algorithm and try to code one for ourselves. Oh yeah, I guess I didn't mention this, but we'll be coding an algorithm right now, right in this event. and you'll be working with it on real life data too. So you'll have real life data that you'll work on with your algorithm. In this event, we'll do that soon. So uh, I so first off is supervised learning as a subset of machine learning. So what supervised learning works with is labeled data. So what is labeled data? Anyone who wants to just say what labeled data is? Anyone who knows what labeled data is, or can just maybe think from the idea of labeled data? It specifies quite a lot. Anyone? Come on, just put a guess in the chat. I'll give you a moment to think this through. Oh, by the way, it's right here on the screen. You can see it right here on the screen. What uh, what uh, what label data means? Just see it from the screen and answer. Okay, so uh, so I'll continue. What label data is that you have uh, yeah, you have so this is just some sample data I'm taking. First off, this is just some sample data I've gathered, and we'll see how this works. But this is just some sample data. What label data does is I'll call this x's and I'll call this y. Why am I doing so? I'll let you know. But the aim of this, but my aim from this data is I want to do something like from the heights, which I see over here, I want to predict the weight. So from height of a person, I want to predict the weight of a person. So for that matter, I'll call X. So X is also called features in this case. Features are on basis of what? I'll predict my labels, which is Y. So Y is my label, which I want to predict. And X is the feature on basis of which I'll predict. So in this example, there is just one feature. As you can see over here, I have just one feature, but that is not necessarily true. You can even have some data which has multiple features. So this is my first feature. Okay, I'll name this 0th feature. This is my first feature, second feature, and so on. I can also do that. I can have a number of features. So that's what label data means. By label data, I mean I have the I already have the features on basis of which I want to predict the labels. And as you can see, Y is my label, and I also have the label values over here. So that is what makes it label data, because I have labels of it. So again, considering that this is just an introductory session, just a starting point, what we'll do is we'll not, for our purpose of this session, we'll not be going deep into the maths behind this, but I am the guy who loves math for these algorithms. And I don't know, you can see my YouTube channel. I have quite a few talks about the math behind these algorithms. But for the purpose of today's talk, we'll not be going deep into the mathematics behind these, and instead we'll focus on implementing them. So let's do this. I have some data like this. I have some x's on basis of which I want to predict my y's. Let's plot the x's and y's. What I did is I just so you see all of these values over here, x's and y's. I just plotted them on a graph, and this is how they look in a graph. Great. So now I have my data plotted in a graph. What do I want to do now? I want to do something that I can, from the values of x's, which is over here, my x-axis. On basis of this value, I want to predict I want to predict my Ys. So how do I do that? I'll give you a moment to think this through. Any ideas you get about how could I possibly do this? How could I just plotted these points, and on basis of one I want to predict the other one. So on basis of X I want to predict Y. How do I do that? Okay. So what I'll do in this case is, as you might have seen, I know these are very little points, very little data points, but it's just an introductory session, and we'll be exploring these concepts. So this seems to work. What I'll do is, if you see clearly, you can make a fair enough approximation. Notice I'm saying a fair enough approximation. So at the end, what you need to do is find a relation between x's and y's, right? So I can make a fair enough approximation that this is a relation between my x's and y's. Again, this is not perfect. A perfect relationship would be something like this, covering all the points, but that's again not a good thing to do when doing ML or ML applications. We that's a bit out of the scope of what we'll be covering today, as this is just a basic session. But uh, but this seems to be a good enough approximation of finding a relation between the x's and y's, and this is what is called linear regression. So this is one of the first algorithms, uh, and it is just, as you can see, so simple, drawing a line around the data which can best approximate the data. So a bit of history, I'd say, but linear regression was, I think, I don't remember the date, but developed somewhere in the 1900s or 1800s, I guess. But it was then used for a wonderful problem. So at that time, it was used for the problem that I have a pea pod and I want to predict the number of peas inside the pea pod by the height of the pea pod, by the length of the pea pod, by, I don't know, height of the plant, and so on. They had all of these features, and that's what linear regression was first used for. So just a bit of how linear regression actually developed. But now I guess you might have a clear idea about why this line tends to work as a good enough approximation. So that having covered, as I said, I don't like definitions and stuff, so I just gave you an example of how you might use linear regression. That's supervised learning. Another subset of this, which is again important to know, is unsupervised learning. In unsupervised learning, I have unlabeled data. So now you know that what labeled data means. What would unlabeled data mean? It would simply mean I have, so earlier I had this Y column over here. I had the Y column over here. I no longer have this Y column. So that's what unlabeled data means. Okay. So then you might ask me, if you no longer have the Y column, what are you trying to predict from this? Right? So that's actually a good question. So I have values of two features, which have to be called feature 1, which is x1, and my feature 2, which is x2. So what I want to do from this is, I want to try and find some patterns out of this. I have a lot of data like this. Again, just some sample data. What I want to try and do is find patterns from it. So from values of x1 and x2, I want to find patterns from the data. So again, like the previous approach, let's just plot the data. And this is how my data looks plotted. Again, the x-axis over here is one feature, The y-axis over here is the second feature. So I have two features and no labels I want to predict on. And I want to find a pattern between this, a pattern in the data. How do I do that? Any guesses? So you might have seen that I can make a good enough, I can kind of separate all of these points by doing something like this. I'm saying this is one set. I'm saying this is my set number 2. This is my set number 1. And this is my set number 3. I guess you understood it. And what did I do? I just made a fair enough separation between all these three. So one of the best examples I can think of as of now, of course, we'll see real life examples and implement them ourselves very soon. But one of the best examples which I feel is pretty much related to this and is kind of customer segmentation. So let's say you have some data like has a customer paid his credit card loans on time, or what is the amount of balance that is there in a customer's credit card. Then with some kind of a segmentation, you can know that which person would pay his loan back or which person would not pay his loan back. Again, this is just an example, but it's pretty much doable. Well, I also have a project based on that called credit risk estimation. That's exactly the same data. And maybe you can check that out on my GitHub if you're interested. But yeah, that's about it. With these data, I can segment all of my data points. So next time, if I have a data point over here, something over here, I can say that it belongs to group 1 and it would have some similar properties of that of other data points of group 1. Exactly what I did. And this is what is called clustering. Yeah, this is a simple clustering example again. So that was about supervised and unsupervised learning, parts of machine learning. There's also another part of machine learning called reinforcement learning. And some people or I would say rather say some sources classify reinforcement learning under unsupervised learning, but as of this event or this talk, I would say reinforcement learning as another branch, except supervised and unsupervised learning. So we'll not be going into reinforcement learning today, but just a high level overview about it. Reinforcement learning is something where you use something like a reward and loss based system. So it's very much used in games, and just think of it like a game. So in a game, if you do one action, you get either a loss or a reward. So it's exactly like this, and that's how it works in reinforcement learning too. When the model or the machine learning model performs an action, it gets a loss or a reward on basis of which it learns. So it wants to try and maximize the profits or the rewards. But we'll not be going deep into that for as of this talk. So let's go ahead, and we just explored two very simple algorithms. Let's put them into practice with a demo. So I have flashed the links over here, and you can you can quickly note them down, take a screenshot, or Vijaya will also be posting the link right now in the chat. So these are the two links for the demos, and I'll give you a moment to note this.
So I think Anush, right, has a bit of an issue with regards to typing in messages. So if you have any doubts right now, you can feel free to unmute yourself and ask us anything right now before we continue on.
Oh yeah, sure.
And I've posted a couple of the links in the chat, so you can quickly go to the site, bookmark it, and come back over here. So we'll just take 2 minutes. Like if you have any doubts right now, please feel free to unmute yourself, ask us. So there's no things. Come on, guys. And then I'll start my part basically. So you want to show the now it's just going to show you those now you can see on the screen, that's the GitHub repository. You can go ahead and you can fork it or start it. Okay, and can you show the other one, the Azure ML one, Rishit?
Oh, what I'll do is I'll come to the here's the Azure Ml one. But I'll come to this in some time.
Yeah,
about what this is all about. But I pasted the link there, so you can have all the links together.
Yes, the breast cancer Wisconsin dataset. So classic. It's so famous.
So Vijaya,
So I'll go ahead.
What I wanted to before you go ahead, I just explained everyone how all of this works, but there's a popular notion that for doing machine learning or deep learning, you require a lot of hardware and a lot of these stuff, a lot of hardware, GPUs and stuff. And I don't know, my laptop is not that powerful enough that I can do these things. So how do I still use these?
And that's where I come in. So I'll be going through the couple of options that you guys can do. For example, even my laptop isn't that great. Even if I have an Ultrabook with me right now, the Dell XPS 15. But the issue is that even though it has a good GPU, right, it doesn't have that dedicated memory for deep learning based tasks. So I'll be showing you a couple of options. Don't worry about that. So right now I'll be presenting you my part, and we'll talk about how you can start learning AI. So one moment, guys. So can you guys see my screen right now? Rishit?
Yeah.
Is it visible?
Yeah.
Okay.
Yeah.
So of course, this is something that people get kind of scared when they hear the word math. Okay, but AI does have a few prerequisites. You don't have to be a PhD in math to actually learn AI and machine learning and deep learning, but you should have some background knowledge of it. And if you face any difficulty with like a certain algorithm, you can definitely refer to multiple sources to actually study that mathematical portion and come back to your machine learning portion. So I would say math is a requirement, but it's not a hard requirement as in you have to learn everything and then you should go to AI. It's a soft requirement, that is you have to learn, while you learn AI and machine learning and deep learning, you will also learn math. So the main topics I would say that are important are statistics, probability theory, linear algebra, calculus, optimization theory, artificial intelligence. And there are multiple sources, and I'll be showing you those links as well in 10 minutes, I would say. So if you're a person who likes books like me, okay, I'm old school in this case. So you have Mathematics for Machine Learning by Mark Peter Desenroth. It's a very good book, I would say. I've gone through the entire book. It's amazing. I even ordered a physical copy. I have actually a digital copy as well. So it's an amazing book. Also on Coursera, one popular source is Coursera. We'll be talking a bit more about Coursera a bit more in in 5 minutes. So you have Imperial College London's Mathematics for Machine Learning. It goes through all the important basics like linear algebra, eigenvectors, eigenvalues. It goes through the important matrices that the background that you should know. It goes through the important multivariate calculus topics that you should know. Even free code camp has very good resources, especially in math as well. So they have a couple of videos on YouTube. I'll show them to you right now. And one famous thing about the famous online resource is MIT Open Courseware and Stanford's Open Course lectures on YouTube. So MIT has a lot of very good lectures, like especially in math, like multivariate calculus, linear algebra. It has very good. It has amazing lectures for AI and machine learning. I referred to them for my classes, and I got straight A's because of that, because of those lectures. They're amazing. Next up, so if you want to go with machine learning and you want it to be a bit more practical in nature, there's a very good book by, I'm sorry, I'm going to mispronounce his name, Aurelian Gajanan. So his now this book, okay, it's currently in the second edition with 200 extra pages, so it's even more in depth. So it's called Hands-on Machine Learning with Scikit-learn and TensorFlow by O'Reilly Publishing. It's really good because and it goes through all the important topics, and it's, I would say, the best, like, one of the best books for machine learning. And of course, you also have the very famous and very well-deserved praise, like, machine learning by Andrew Ng course. It's really good. It's on Coursera, by the way. So now here's some links. Of course, I'll be posting them in the group as well. Don't worry about this. You have open. This is the main website for Open Courseware by MIT. But you can just quickly search on their site as well. I'll show you a couple of links. Free Code Camp has guide to tutorials on data analysis with Python and TensorFlow as well, and machine learning as well. I'll show you those as well. And of course, we also have Coursera. And in addition to this, of course, we also have some important important, what do you call this, books. Okay, so once you've passed that beginner stage, I would say, and you're like in the intermediate stage for machine learning and pattern recognition, the Bishop book is amazing. Okay, initially for beginners it might be a bit too dense to read, but beyond a certain point you will be going and once you have a good foundational knowledge in all your math and etc., this book has really good insights and goes through the math very beautifully. And of course, and if you want to be very light read, okay, if you want still learn about some background in machine learning, your machine learning earning by Andrew Ng. This book is also a really nice read to read on the couch when you're sipping your tea or coffee. So deep learning. So deep learning is a bit more in depth, I would say. So if you want to do the deep learning in a more practical sense, I do recommend the deeplearning.ai's deep learning specialization. It's amazing. It's well worth the price. And also, I'll also talking about the options of Coursera as well. Yeah, and if you're more focused on class, you can go for deep learning with Python by, I'm again going to mispronounce his name, Francois Cholet. I don't know, sorry guys. And then you also have the amazing book called Deep Learning just called Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Cole. These three guys are legends in the deep learning community. They're amazing. And of course, with deep learning, you have a quite a huge selection of frameworks that you can use. You can use TensorFlow, you can use PyTorch, you can use Gluon, Theano, Keras. Keras is actually more of an API for TensorFlow, but I'm just putting it out there. You have Cafe, MXNet Chainer, and of course, we also have Microsoft CNTK. And if you are a person who likes cloud computing and who wants to just learn how to deploy cloud solutions for deep learning or machine learning, you have Azure ML, and Rishit will go into detail about Azure ML and the demos a bit soon. Okay, so now I'll just quickly show you guys. I'll be sharing my screen again, and I'll show you guys the couple of resources that you guys can look at. So one moment, guys. Thank you so much for waiting for me. So as Rishit has asked, suppose you don't have what do you call this a good GPU, a good PC build or whatever it is. Like majority of us don't have it, of course, because it's kind of expensive, and yeah, that's the thing. You have Google Colab. Okay, now for transparency purposes, I am using Colab Pro because I am currently doing some research work as well. So I've paid for it. It's like $10 per month, but you usually get a P100, and it's actually worth the $10 if you're using it for almost every single day. It's worth it. So this is one small demo I would like to show of TensorFlow. So this is actually my topic. So this is thyroid classification. So one common type of cancer in thyroid is called papillary thyroid carcinoma. And I don't want to show too much about it, but you see that this is the basic code. You can run code in this notebook, and then you can just start running stuff on it. Let's go on. So you have a couple of options for deep learning. Okay, so you have cloud options, and if you're a student member of certain organizations, you do get that for free credits. For example, we have Azure Credits. Rishit, for GCP, do you want to give us more insight about that?
So, as Vijaya said, Collab is completely free for everyone. You get everything you want to do for free in Collab. In fact, so as Vijaya mentioned, you can get a couple of free Azure credits. are doing thesis there with GCP2, you can when you kind of when you kind of make a new account, you get $300 of credit, which would pretty much be sufficient for beginning out.
Yes. So you also have Collab, and you also have Azure as well. So you have Azure Machine Learning and everything else. You can also deploy notebooks in Azure Machine Learning, by the way, with the VMs. So there are many cloud options for you people, especially if you're part of any kind of if you attend events, they usually give you coupons for these kind of what do you call it, credit. They give you credit coupons, etc. So you have options as well, and you also have Kaggle as well. Kaggle also is it's very amazing for data scientists, machine learning people, and deep learning people. So in Kaggle, it's basically like this. So it's like lead code for ML people. Okay, I would say. So you can download datasets. You have a dataset section if you want to do your work locally. It's amazing. You also have notebooks in which under datasets you will have what do you call this notebooks. So you can run notebooks even in Kaggle will provide you notebooks, and you can like run them on GPU, and you have a limited time for GPUs, but you can still run them on GPU. So and they have a really good forum for talking about several competitions and stuff like that. So if you do want to get into the competitive aspect of ML, I do recommend that you start making a Kaggle account and start working on it. And of course you also have jobs, but that's all there as well. So you can also apply also there. So having a Kaggle account is very good, and it's like a boost to your CV. So okay, speaking of this, okay, so Coursera, okay, the thing is that you can audit a course, and by auditing a course, you can just access the materials, the study materials like the videos and all, but you might not have access to certain assignments and all. So that's one downside of auditing a course. But Coursera does have an option for financial aid, so you can apply for financial aid or scholarship. And I think many of our Indian universities have gotten us Coursera what do you call this free use till September. So you can also use that time well, and you can start studying for like studying these courses. So you also have the option of financial aid. And of course, we also have free code camp. They have amazing. They have started giving tutorials for math as well. So your math programmers, algebra, statistics, data science, and your TensorFlow and 2.0 in 7 hours. So you have so many options. So you have many free options as well. So this is one thing. So I'll just cut down, go step by step actually. I'll be giving all these links in the chat, of course, soon. So don't worry about that. So you also have TensorFlow. In the TensorFlow website itself, it has a very good guide for TensorFlow. So it has a very good online guide. You also have the API as well. So the documentation is very good. They have tutorials. They have like the guide steps like how to transfer learning and all. So that's there. And of course, if you want to go more into the cloud, you have Azure. You have these learning paths like build AI solutions with Azure Machine Learning. But I think some of these require an Azure subscription. So I do recommend that anybody who's pre-alpha right now to finish their Azure fundamentals course, first get upgraded to alpha, and then get your Azure and start working on these learning paths. And you also have those certifications as well. And that of course requires a Azure AI fundamentals thing, and you require Azure fundamentals as well. So and of course, this is one very popular course by Stanford, the Convolutional Neural Networks for Visual Recognition. You can see the videos online, and then you also have these slides and notes as well. So you have so many good free options. Okay, and of course, here we go to MIT Open Courseware. So MIT Open Courseware is also amazing. You have free lectures for mathematics on machine learning. You have AI. You also have machine learning. And I've taken all these courses, and I can say they really help you, especially and if you're planning to take an elective in your bachelor's degree, for example, or even a minor in that case. These courses will help you out so much because they are so in depth, and they go through many possible and many combinational possibilities. It's really good. So it's well worth your time to go actually take a look at these courses. So this is all I have right now for your AI and machine learning and resources. So as you can see, there are many on free as well as paid courses as well. So you have both the options. I do recommend the Coursera one the most because, of course, they do cost money, but they're worth it, I would say. And if in the specialization, I think you pay per month, and if you finish the specialization within a month or two, it's amazing. So hi guys, this is me. Don't mind the avatar over there. I made it in Inkscape within 5 minutes. So I'm Vijaya. So I mostly focus on ML and DL, and of course I spend my time doing writing research papers, and they're currently, of course, in review. And right now I'm also learning a bit of web development and lead code as well. So, and I'm also working on a couple of personal projects. I might share them soon. So thanks a lot, guys. And you can follow me on Twitter over here at VijayGB over here if you want to like connect with me. So yeah, thanks, guys. So I'll be passing it on to Rishit right now. He'll be going on the about the Azure ML demo. So please go ahead, Rishit. And in the meantime, I'll be posting links in the chat. Okay.
Great. So before we move forward, we have a question by Patricia, who's asking that you just shared all of these resources, but where should a beginner start with? So what I would like to add to this is, if you're a beginner, you just kind of walked your way through this event, this talk. So I'll now be showing you demos and notebooks on that. So first off, I have some 3 or 4 demos which you will be able to try out for yourself in Google Collab, which I just showed, completely free to use. And you can try out those demos for yourself. They're super easy, just with the amount of things we just covered before we just talked. So you can start with that, work your way through all of the code that is used in the demo, understand it completely. And Vijay, anything you would like to add for beginners
So
from all of
I
these
would
resources?
say for beginners, I do recommend Andrew Ng's courses for machine learning because they're slow. He goes through them very slowly, and he does it like step by step along with the math. So it's very. I would really recommend that you take Andrew Ng's course on machine learning on Coursera. The videos are available online as well for free to view. But if you want to attempt the submission, the assignments and all, right, I do recommend that you pay for Coursera and the course and then take them. So as Rishit is going to demo that Azure ML, I'll be posting the links right now. So Patricia,
Great.
so I do recommend that you do take the course. I'll just send the link to the course right now.
Great. So while Vijay does that, we'll move on to the demos part. So this is what the demos part is what I'm really excited about. Kind of the the most fun part today. So today we talked about linear regression and k-means clustering. We talked about clustering. We'll see a variant of that, a way to do that called k-means clustering. Again, these are very basic and there's a lot more to ML, but wonderful to start with. So first off, let's do linear regression. So remember, I had shown you that slide with a couple of links, 2 links. Those were for all these code files. I'll be showing the slide again. You can also find it in the chat. Just scroll up through the chat history. Great. So let's get started with linear regression. I'm demoing this live over here. So I'm using a private server, which gives me higher performance. But I completely understand that not everyone might have access to this server. So you can go to the GitHub over here for this talk, where more of these resources will be added from Vijaya's end. So you can just take up any of these demo notebooks. So let's just go into linear regression notebook, and you can find all the code files over here. Also, what you can do is you have this button on top of here called Open in Collab. So once you press this button, the notebook will open in Collab. I'll show that right over here. You can open the notebook directly in Collab and start running over there.
Oh yeah, Rishit, after you, I'll just demo one notebook as well. I kind of forgot to demo that thing, so I'll just do that. Up to you. Go ahead. Please go ahead first.
Oh, no problem. So when you click that button, you'll be taken to the Collab working of this. So I just press this Open in Collab button, and I ended up on the Collab screen, and I can do everything which I would normally do. Great. So what we'll do as a demo, as an example, is we'll be using scikit-learn. Scikit-learn is super easy to use. I hope you can see the text written down over here. I've zoomed it quite a bit. And what we'll be doing is we'll be implementing linear regression for weather conditions. So we'll be predicting weather conditions with linear regression. So let's do that. First off, let's make a few imports. What I also assume is you know a bit of Python. So I assume that you know a bit of Python. Let's go ahead and read my data. So the data set that we are using today is present on this URL. You do not need to explicitly download it. You can just pass in the URL into a read CD and it will download it itself. So just go to storage.rishit.tech/storage and this URL, which has the data set for today. So by the way, just worth a mention, I have this cool repository of open source datasets, which I have specifically worked on, which I have put together, and you can find it on my website rishit.tech. You can download any dataset from there, use it for your learning purposes. So let's go ahead and read this dataset. What's this? I didn't expect this. Give me a sec. This is absurd. Oh, I guess I made some issue in typing out the link. So really sorry with that. I'll fix the link in the repo for this. I have my local data right over here. So let's go ahead and use that instead. Okay, let's do that. So what I'll do is I'll just copy the path, paste it over here because I want to read it from here. And it's called weather data. So I'll just remove this part. So it's in weather data, summary of weather.csv. So let's go ahead and read this. So this is how my data set looks like. I have all of these parameters and I'll predict my weather from it. Let's do this. So let's make a plot of this. And this is how my minimum temperature and maximum temperature looks like, which is what we'll be predicting today. So do you notice something cool in this? It's pretty much like a line. So a linear regression would work moderately well on this data set. So let's go ahead and do that. I have made a few more plots which confirm the same, but as of this one, as of this talk, we'll not be going into that. If you're interested, all the code is present in the GitHub repo. I'm just reshaping my arrays, some pre-processing, which is different for almost every dataset. Let's go. Let's come to the important part, the part which I actually want you to see, which is building your model. So let's go ahead and do that. So what I'm doing is, first off, I'll split my model into a training data set, which you can see over here, and a testing data set. So testing data set is the part of the data which my model has not seen, and it will try to predict. So let's do that. And what I'll do is I'll call it train test split. So I want to split my data set. Let's do that. Let's come to the part which is training the model itself. So remember me telling you that this is a linear regression model. So I'm just specifying that I want a linear regression model and I want to train the model, which is I want to fit it on the data which I have. So I'll just call a fit, pass in my X values, pass in my Y values, and fit the model. So a question to everyone: this is a line, right, which predicts the which is a linear regression essentially makes a line on the data. So what do you need for a line? Some elementary school mathematics. What do you need for a line? What do you need to define a line?
Here's the hint, guys. Y is equal to mx plus b.
I think slope.
B. Oh, that's right. Slope and something else. slope and intercept.
Yeah, what's
Yeah.
B?
And the
What's B?
constant means where it begins. MX
Yeah,
plus C, right?
yeah,
Yeah.
mx plus C, and
C
C is the
Intercept.
Yeah,
correct.
or the constant where it begins.
intercept. Yeah, intercept.
Perfect.
Great. So I made a line. Let's get the intercept and coefficient or the slope. So let's do that. I can see that my intercept is 10 and my slope is 0.92. Okay. I don't understand these values of slope and intercept, but they are not for me. They are for the model to make predictions. So let's try actually predicting with the model. So what I'll do is I'll just call dot predict. Let's run this. And I made a couple of predictions. So you can see that I made almost 23,807 predictions, which was my test data set. So let's see. So my first label, which is the actual value was 28.88 and I predicted 33.67, just as an example. So those are my predictions and let's run this. And this is how my line looks like. This is the line I just built on top of this data. And that's about it. We just successfully built a line on top of the data, which can predict, which can pretty accurately predict weather. So, so just think about it. If the line is somewhere down over here, somewhere down, then it would be a bad sign for the line, right? So it needs to be as close to the data as possible. So I'm just seeing a few metrics or a few metrics for my line or my predictions. So I can see mean absolute error, mean squared error, and RMSE or root mean squared error. You don't need to understand what all of these mean at this stage, but for now you can understand it as the error in my model. So the lower the error is, the better it is. Root mean squared error is the one I want you to see, as root mean squared error is a normalized error and it is also in the units of the data. So my root mean squared error is almost 4.19, which is good enough, but I'd not say very good. It's a good enough one, but we just ran the model. We just made a very simple model just for understanding purposes. So I'd say it did a pretty good job on the root mean squared error. So that was about linear regression. We just applied it on a real life data set. All of the code is present in GitHub. Let's quickly go over to the clustering example. For the clustering example, we'll use the Iris dataset. Iris dataset is...
I'm also going to use that. Nice. Go ahead, go ahead.
Oh, great. So Iris is a pretty popular dataset. Again, you can run this in Collab just as the last one. Forgot to mention that. So let's go ahead, make a few imports. We'll run through this pretty fast since we are a bit out of time. And so I'll try to make clusters around this. So I'll not go over the code, super simple. You can go over it yourself. So what I'm trying to do is Iris is flowers. So from the petal length, sepal length, petal width, you are trying to predict which flower it is. So so what I'm trying over here is 8 clusters. Remember that diagram I showed you? I'm trying to make 8 clusters in them. So I'm trying with a number of I'd say a number of cluster values. You have to experiment and find the best cluster value. So I can see that 3 clusters over here gives me a pretty good I'd say gives me a fair enough discrimination in the data. I can see 3 classes being separated well enough. So so that seems to be a good one. Let's go ahead and start. So ground truth is something that is actually there in the dataset. So my dataset 2 had 3 clusters like this. So I just experimented with a bunch of values. For now, it was what, just 3 values. But and then I found out that 3 clusters, or the model we just made over here, this model does a pretty well job on the dataset. So that's about linear regression and k-means. And this was right with scikit-learn. You had to write all of the code yourself. What we'll do now with Azure ML is that we'll make a few models in Azure ML. You'll see how easy it is to make models in Azure ML Studio, and you can use it, and you can easily use them too without writing a single line of code. So, so this is the example for Azure ML, where we'll be using breast cancer dataset to figure out which one is the which breast cancer a patient has. And this is a project by me. So I shared the link earlier. I'll share it again, and we'll be seeing how you can make it with no code. So so by the way, if you like this, just go ahead and hit the like button. It's on Azure AI Gallery. Great. So when you start out with Azure ML Studio, as we are already running out of time, I'll be just giving you a small intro to Azure ML. This is where you'll be making any experiments, or you'll be doing your main stuff over here. So what I can do is I can just create a new experiment and stuff like that. So what I can also do is I can import data sets. So let's say I want to import a particular data set, I can upload it from a local file too. We'll come to see where what Azure ML allows you to do and how you can do it. What you can also do is have a web service which can serve your model. So again, this makes it easy to do it with just a couple of button clicks, but you can also serve your model with this. So let's see an example of this. Let's see example of the demo we are going to make today right over here. So the demo, so this is the finished demo which I'm showing to you. Let's do it right over here. I want to do test. Okay, so what I can also do is I can enter a number of values over here and from my data set and see if it is which type of breast cancer it is, or let's see the web service for this. Let's go over here. So Azure ML Studio allows you to make a web service for this, where you can serve your model very easily to your end users. So this is not production ready, I would say, but it allows you to do this very easily. So while this loads, we'll take a look into Azure ML. So this is how your experiment will look like when you do it. When you go over here, which is the URL that I shared, you can just do Open in Studio Classic, which will take you to this screen, which we'll be seeing right over here. Great. So let's zoom in a bit so you can see it better. So right over here on the left hand side, I can see a couple of experiment items. So we'll go over them. Experiment items are essentially all of these blocks which you can see over here. You can find each of these blocks in the experiment model. So let's go to machine learning. And I'll come to this part instead. That would be better. I can see the saved data set, my data set. I have uploaded all of these data sets for my for experimenting with Azure ML. So I can just select this, drag and drop, as simple as that. And I just imported the breast cancer data set, which is what we wanted to use. So let's do this. And first off, I'll be removing all the duplicate rows in the dataset. So let's say I have 2 rows which are same. I'll be removing it. I'll be then cleaning some missing data. So if my dataset that has some bad values or does not have some values, I'll be cleaning that. What I'll then do is I'll split my data. So remember training and testing. So this is the dataset 1 from one node. This is the dataset 2 from the second node. What I'll be doing then is I have two models over here. If you see, I have a multi-class decision forest, which is for now you can understand it as an algorithm, and here I have a neural network. So just see, I did not explain to you about how a multi-class neural network works or a decision forest works, but you are well able to use it over here. So you don't need a lot of experience to work with this and can get started right away into making projects. So I'm training these two models on the same data. What I'll do then is I'll score my model. So I'll see which one of these both models is better for this purpose, and then make it as a web service. So let's go ahead and run this. So Azure ML Studio is pretty fast too. I'll be able to run this very soon, and you can see the outputs. Great. So you can, it ran so fast. So I can just see finished running. It has trained my model with these both models you see over here, these both algorithms you see over here, multi-class decision forest and neural networks. I have a lot more of these. Let's just search a common model which I know is there in Azure ML Studio, called Logistic Regression. So let's say I want to use this model. I can just drag and drop it over here and use that one instead. So that's how easy it is. Let's delete this one. And what I do want to do over here is you can select any node over here. So let's say I select this node and do a visualize. So I can visualize it right here in the Azure ML Studio. I can see what my data has and stuff like that. A few graphs too. So let's do the same with my final outputs, which I really which I care about for this demo. Great. So I see two of these over here. So let's scroll down. I can see that I trained two models, right? A multi-class decision forest and a multi-class neural network. So I can see the outputs of both of these models. So I can see that our multi-class neural network had 99% accuracy almost, and our decision forest had 98.8%. So that's pretty good. You wrote no code and you could do pretty lot of stuff with this. So I feel that's cool and it's worth giving a try. So what I'll quickly do is I'll switch to my presentation screen. Give me a sec, I'm just switching.
Yeah, go ahead, no problem, dude. Please.
Great. So that was about the demos. You saw linear regression, you saw k-means, you also saw Azure ML Studios, where you can start building complex models without having to write a single line of code. Well, you can also write code into Azure ML. That's well possible.
I'll just quickly demo my part as well. So I'm going to give you guys a small demo on the deep learning part of Keras. So I mean of TensorFlow and Keras. So shall I share my screen, Rishit?
Yeah.
Sure. So I'll just switch.
Yeah,
Okay.
yeah,
So hi guys, can you see it? So I'll just do it a bit fast. Okay. So I'm using three main important things. I'm using TensorFlow, Keras, and Scikit-learn. Scikit-learn for the dataset as well as all the for all the other helper functions. So as Rishit has done, the iris dataset is also a classification dataset in which you have to predict three classes. So the problem set is, given the dimensions of petal and sepal, can we predict the species of iris? So you have three classes. You have Setosa, Versicolor, and Virginica. So you have three classes. So class 0 is Setosa, class 1 is Versicolor, class 2 is Virginica. So I'm just importing the dataset over here. So you can, this is like all the this is showing the distribution of all three species of the irises. And I'm just showing it to you guys again how it's working. So you have so you have Iris over here, of course, and I'm creating my small deep learning network over here. So I'm starting. So of course, just like how Rishit has done, I am of course doing the train to split, and I'm putting it 80-20 split. I'm creating a deep learning network over here. First layer has 4 neurons. For second layer has 5 neurons, and this is the hidden layer. And since I have three outputs, Setosa, Virginica, and Versicolor. I'm going to have 3 output nodes. So and I'm compiling my model over here. So I'll just run this. It won't take long. It's a very fast network. So this is how you can see our network is like, looks like. And you can see right over here how it's done quite fast. Okay, so I'm just showing it to you guys once again. So as you can see, the losses at each iteration, the loss is decreasing, and the accuracy is actually increasing. So I evaluate on my test set, and I've gotten such good results over here. My test accuracy is actually complete. It's gotten full. It's 100% accurate, and my test loss is 0.018. And this is just the predictions and all. So confusion, and I'm showing the confusion matrix. So confusion matrix is also an important thing, but in machine learning classification, like it asks, it just shows you how many number of samples have been classified properly. Ideally it should be all diagonal elements. So you can see all diagonal elements over here. So 9, 13, 8. So you can see all our metrics over here: precision, recall, F1 score, support, all of them are 1. And this is just for plotting our loss and accuracy. So you can see how even a simple neural network is able to classify the multi-classification task. So you can see how well at each iteration our loss is decreasing. Or each epoch, I would say, and at each accuracy, the accuracy is gradually increasing, and it's finally almost hitting 1, of course. So this is my demo for showing you guys. I'll send this I'll put it on GitHub and link it in the chat as well, like a bit later. I'll do it later, of course. So this is like one example of using deep learning. So back to you, Rishit.
Okay, that was indeed a wonderful example, and just for so a lot of you might be trying about machine learning and stuff for the first time. So the 100% accurate model is just because it was
a small data set.
Yeah, a small data set, an understanding based model, and you would not see 100% accurate models for sure.
It's actually quite a rarity to actually even get to hit one, and so
it's usually overfitting.
Yeah, so usually overfitting. We can talk about that a bit in more detail in the next session about overfitting, underfitting, different things. But one thing to remember about machine learning is that it's an iterative process. So you first create a base model, you train it, you get back the output, you see what's wrong, you again tweak it a bit, you tweak the hyperparameters, you again iterate through. It's a very iterative process, I would say. So in most cases you'll be staying at a strain, like waiting for the model to finish training. So don't worry about that. So that's part of the AI process, I would say. So in this small data sets, okay, so you might easily hit a 99%, but on large scale data sets, like at least like 7 gigabytes, 10 gigabytes, even 30 megabytes, if we I mean gigabytes actually, if you're dealing with, suppose in my case I work with histopathology images. So in that case, if they're whole set images, they're like gigapixels and they're extremely large in number. So that's actually a challenge. How do you classify a whole set image along with the memory constraint and all? So it's a very good challenge indeed. So as you keep exploring, you will tend to actually focus on one kind of topic. In my case, it's medical images, but it's fine. We all have our niches and interests. So please explore as much as possible in ML. See what topics you like. Iterate through this process. See which parts of topics you like, and you can focus on that as your as your main specialization, I would say. So the floor is open, guys. If you have any doubts and any questions, please go ahead.
Great. So I'd also like to add, we have all the thing which we covered today, starting with ML, k-means, linear regression, a bit of deep learning with k-rays. A larger portion of it is available at k-means at this URL. It's a blog post by me, and you can understand how actually k-means works, the maths behind it. I'm specifically linking this because we explored k-means today. And if you want to know more about deep learning with TensorFlow and deep learning in general. More about it, how you can classify images and stuff, a bit more advancing. I maintain this blog series called Deep Learning with TensorFlow. The link is right here on your screen. And yeah, you can take a screenshot or something like that. Great, I guess then.
So, guys, if you have any